Okay, here we're going to look at question 6, which came up in 2015. A loaded test tube of mass m floats in water and is in equilibrium when a length d is submerged as shown. The upward force exerted by the water on the test tube is F. Given that F is directly proportional to the submerged length, find the constant of proportionality in terms of d, m and g. So we're told that F is proportional to the submerged length. Now you can see d is the submerged length, so F is proportional to d. If F is proportional to d, this means that F equals some constant times d, and we're going to let K be that constant of proportionality. Now here the test tube is in equilibrium. This means then that upward forces are going to equal the downward force. The upward force we're told is F, and the downward force then is going to be mg. So here F will equal mg. However, we know that F also equals K times d. So we're going to replace this F with K times d. And we're trying to get K on its own. The constant of proportionality is what we're looking to find on its own. So K then is going to equal mg all over d. In part 2 then, show that it will oscillate with simple harmonic motion and find the period of the motion. Now, if we push the test tube down some further distance s, and you can see from this diagram, the length here, the submerged part of the test tube then is d plus s. Now, it's no longer in an equilibrium position, so the force was applied in a downward direction, so the acceleration will be downward. The upward force then is going to be K times the submerged part of the test tube, which is d plus s. So if we formulate the equation of motion, resultant force is ma, and that's going to be the downward force, which is mg, minus the upward force, which is K times d plus s. So the resultant force is the downward force minus the upward force. Now the K value, we work that out as mg over d. And if we multiply d plus s by mg over d, this gives minus mg over d times s. So this plus mg and this minus mg will cancel out. So ma just equals minus mg over d times s. And the m's will cancel, and a then just equals minus g over t times s. This implies it's simple harmonic motion, and the angular velocity omega equals root g over d. So we're after proving that it does oscillate with simple harmonic motion. Next of all, we have to find the period of the motion. So t equals 2 pi divided by omega. So t is going to be 2 pi divided by root g over d. Instead of dividing by that fraction, we can turn it upside down and multiply. And this means then t equals 2 pi multiplied by the square root of d over g. Part B then. We're told that a skier of mass m kilograms is skiing on a hillside when he reaches a small hump in the form of an arc AB of a circle with centre O and radius 7 as shown in the diagram. O, A and B lie in a vertical plane, and OA and OB make angles of 22 degrees with alpha, 22 degrees and alpha with the vertical respectively. The skier's speed at A is 8 meters per second. The skier loses contact with the ground at the point B. We want to try and find the value for alpha. So what we're going to need to try and find out is the distance A and B are both above O. Now the distance from O to A is 7, and if this angle is 22 degrees, then if this is a vertical line, this angle here would also be 22 degrees. So if that's 7 and this angle is 22, this vertical height is going to be 7 cos 22. If we do the same at B, again, if that's alpha, this angle here would be alpha. The distance from O to B is 7. That means this vertical height is going to be 7 cos alpha. So we're going to first of all start by using the principle of conservation of mechanical energy. And PCE states that the total energy at A equals the total energy at B. Now at A we've got both potential energy and kinetic energy, and at B we've got both potential energy and kinetic energy. Now we do know that U equals 8, the speed at A was 8. And we do know that H for A is 7 cos 22 and H for B is 7 cos of alpha. Now the m's then will cancel out everywhere, and if we multiply across by 2, you get 14g cos 22 plus 64 equals 14g cos of alpha plus v squared. So if you bring the 14g cos alpha over, it subtracts, and then with these two terms they've got a 14g in common. So if we factorize out the 14g, it means that v squared can be written as 14g on cos of 22 degrees minus the cos of alpha plus 64. So we can label this as equation number 1. Okay, next of all, we're going to examine the forces acting on the particle at point B. So we've got a reaction which is away from the surface and the weight which acts straight down. Now we need to resolve the weight into parallel and perpendicular components. So if this is an angle alpha, this is an angle alpha also. And if this side is mg and this is an angle alpha, this component here will be mg cos alpha. Now the centripetal force is the resultant force towards the center when a particle is travelling in a circular path. And for motion in a vertical circle, we always use Fc equals mv squared over r. Now from the diagram, the resultant force towards the center will be mg cos alpha minus r. And that equals mv squared over, and the radius r is 7. Now we can label this then as equation number 2. Now we always sub 1 into 2, and you get mg cos alpha minus r equals m over 7 on, and the v squared was 14g on the cos of 22 minus the cos of alpha plus 64. So if we multiply the right hand side by the m over 7, this gives 2mg cos 22 minus 2mg cos alpha plus 64m over 7. Now the m's will cancel out everywhere, and if we get r on its own, r is going to equal 3mg cos alpha minus 2mg cos 22 minus 64m all over 7. So we can label that as some equation number 3. So equation number 3 gives the reaction for different values for alpha. Now at the point B then, we're told that the skier leaves the surface. So this means at B, the R value is going to be 0. So this means then 3g cos alpha is going to equal 2g cos 22 degrees plus 64 over 7. If we put in 9.8 for g, you get 29.4 cos of alpha equals, and 2 times 9.8 by the cos of 22 plus 64 over 7 works out as 27.31566. If we divide that by 29.4, the cos of alpha then works out as 0.9291. And then alpha will be the inverse cos of that, and that works out as 21.7 degrees.